Hello, everyone. Welcome back. Today, I want to talk about solving polynomial and rational inequalities by hand. I've done another video about solving or about polynomial and rational inequalities where I introduced those. And actually, in that case, we actually looked at how to solve them using the graph. And I also want to show you briefly how we can all solve those by hand. It'd be useful to see that. So our goals would be the same as the previous video to solve polynomial inequalities and rational inequalities. So polynomial inequalities, when you have a polynomial, and it seems you can be written this way, with a polynomial on one side, and then when you read inequality symbols, then 0, like this. That's an example. And then rational inequality, remember rational means like a fraction. So here specifically, we talk about a fraction which our variable is also in the denominator. You're written something like this, once again, where one side can be 0, then it will be an inequality, then another side like this. So we want to see how we can solve those. So actually, we'll look at the examples of both of these first. We'll do these and actually show the process of doing these by hand. And a similar process can also come up in calculus courses in finding places where a function is increasing and decreasing. So let's take a look. So let's go over here to the right, look at the first one. Now I'm going to write it a bit differently at first. This one I'm actually going to write as x squared plus 2x, and then is less than positive 3. Okay, so what we want to look at now is take a look down here on the left at our procedures for doing this. So we want to write the inequality. So once again, we have an inequality. Also, this is not like a linear inequality where we get x equal to 0, or sorry, get x by itself. In this case, we can't do that. So we need some other method to solve it. So what we want to do is write the inequality. So there's a polynomial, a rational function on one side and 0 on the other side. So clearly here, we want to get, in this case, we'll just get or make the right side 0. Okay, subtract 3 from both sides. Then this will give us then x squared plus 2x minus 3 is less than 0. That's the form we wanted in. Okay, so we're going to do then is we're going to call f of x, basically this is going to be our polynomial function here on this side on the left, x squared plus 2x minus 3. Okay, now we'll also simplify and factor it if we can. And this one does factor. It does factor into x plus 3 and x minus 1. That's our next step. Now, find the x-intercepts and values which make the function undefined. And these are important because this is where you can actually change signs. Let me write this a bit better here. So there we go. I want to find the zeros or the x-intercepts and also the places where it's undefined. This is actually where the function can change signs. Okay, and we'll see that. So remember, the zeros is finding the zeros is like finding the x-intercepts. So this one can't be undefined anywhere. There's no x in the denominator, but it can be 0. So the zeros or the x-intercepts, let's do that next. To find the zeros of the function, of course, we just set this equal to 0 and solve. X plus 3 times x minus 1 is 0. Okay, so if this would be a true statement, the left side has to be 0. So anything that makes this factor 0, this factor 0 is a solution. So you set each one of those equal to 0. And you solve. And so we have x equals negative 3 and x equals positive 1. Now, what we do with this then, and we'll just go down to the next page, is we're going to set up what's called a sign chart. So step number 4, use the values found in step 3. Divide the number line into intervals. The sign of the function will remain the same in each interval and only change if the x-intercepts or the values which makes it undefined. So what we're going to do then is, and then come in here with a little more space, let's draw our number line. Okay, here's 0, and here is positive 1, here is negative 3. Okay, and what's going to happen is that as far as the graph goes, remember your zeros, these are the same as the x-intercepts. So the graph is where this function is equal to 0. So what we're trying to find is where this function, the left side, in our case is less than 0, but it could be any of the inequality signs. Find where it's less than 0. The intercepts or the zeros are where the function is 0. Okay, they're the only places where the function can change signs. So what we're going to do then is just make kind of dividing lines here. So in each one of these intervals, our function is going to have the same sign. Okay, so what we're going to do then is look at essentially each part of our function. So we have factors, we have x plus 3, x minus 1, and then the whole thing, which we called f of x. And what we're going to do then is look at the sign of each one and then find the sign of our total function f of x. Okay, remember f of x was this, x plus 3 and x minus 1. So what I'm going to do then, and this is explained here, is pick a test point in each interval. So over here, I'm going to pick these, just pick something simple, -4. I already have 0 here in the middle. And then let's pick, say, 2. What we're going to do then is, once again, we know the function can only change signs here and here. So the function has the same sign in the middle interval and also over here and over here. So you just need to find out what that sign is. So imagine plugging -4 in each one of these factors. Plugging -4 at x here, that would be -1. -4 plus 3 is -1. But all we care about is the signs. This is going to be negative. Actually, let me divide this right here. Okay. So this factor here, if I plug in -4 in for x, will be negative. If I plug -4 in for this one, that'd be -4 minus 1 would be -5, which also would be negative. Okay. Now, since f of x is these factors multiplied together, then the sign of the whole thing, the sign of that whole side, is positive. I'm going to circle that because that's the important one. Okay. Do the same thing in the middle. So if I plug 0 in for x in the first one, this whole thing would be +3. That would be positive. If I plug 0 in here, the second one, that give me a -1, which would be negative. Okay. And of course, positive times negative is negative. So in the middle here, so over here in this interval, it's positive. Over here, it's negative. Okay. Then over here, let's take a look. So we plug 2 in for x. We have 2 plus 3, which is +5, which is positive. Plug 2 into this factor, 2 minus 1 would be +1. That would also be positive. So a positive times a positive is positive. So this shows us then what the sign of our function is in each of these intervals. A little space. Okay, now, so remember our function was, we're trying to find this x plus 3 times x minus 1 was less than 0. Okay, so now I just need to know what your sign is. This case is less than 0. So where is it negative? Well, we found out it's negative here in the middle. Okay, so then our solution is from -3 to +1. In this case, since it's not or equal to, it's strictly less than, we use parentheses because our endpoints are not included. So that's our solution. If our endpoints, if it had been less than or equal to 0, endpoints would be included. If it had been greater than, it would have been these two intervals here, this interval from -infinity to -3, and this interval from 1 to infinity. So that is basically how you use a sign chart then to help you find this. Now, look at the graph of this. Let's do that really quickly. On Desmos, remember it's desmos.com. We graph this. Let's call it y is equal to, and however you want to do it. I'll just do the factored form, x plus 3 and x minus 1. Okay, and this is what we see. So those are our two intercepts, or zeros we found, -3 and 1. As we see, it's below the x-axis, between those two, and above the x-axis on both sides, other sides of that. So that's correct. So this shows us then, we can also do this graphically, but by hand, we can do it the way we just did and find out where it's negative or positive. Okay, let's quickly look at a rational one and work the same way. So let's look at number 2. Let's do this one. X minus 3 and then x plus 2 is greater than or equal to 0. Now here, once again, if one side is not equal to 0, we want to make it equal to 0. This case is already in that form. So we're going to call this f of x is going to be this left side, x minus 3 over x plus 2. Okay. Now, next thing, we want to find the zeros or x-intercepts and where f of x is undefined. Okay. Now, 0, define the 0. And we set equal to 0 and find the x. And so that's going to be x minus 3 times x plus 2 is equal to 0. And here, if you want to think of multiplying, both top and bottom by get rid of our denominator, and this is just going to multiply top and bottom by x plus 2, this then would be, let's go down to the next page. This would give us just x minus 3 is equal to 0. So actually only the denominator in this case tells us where a 0 is, and that's just going to be x equals 3. That's going to be our 0. Okay, that's for one place it can change sign. And then where it's undefined, so look back at our function. Remember, undefined means the denominator is equal to 0. So look at that. Generally, what you do is you set your denominator equal to 0 and solve. And here we can see that if x is -2, our denominator will be 0. So basis where it's undefined, and basically that's x can't be -2. Okay, can't be because it can't be, denominator can't be 0. Okay, so what that tells us then, so our sign f of x can change signs from positive, negative, or negative, positive at these two places, x equals 3 and x equals -2. Okay, and those are the only places it can change sign. Doesn't mean it will change sign there. Those places where it can change sign. So as we did before, we're going to take our number line. Actually, I'm going to do this slightly differently this time. So I just realized I just erased that, but that's okay. So, all right. So here is 0. Here's -2, and here's +3. So once again, I'm going to draw dotted lines here. It's indicating these are the places where it can change sign. Okay. Then as I did before, this time make a separation line here. Look at my factors, which make up my function. So our two parts are x minus 3 and x over x plus 2. So we can look at x minus 3, look at x plus 2, and then the signs of those are going to give us a sign of the entire function, the left side, which are called f of x. Okay. Now, in the same way, here we're dividing, but it works the same way. So a negative divided by a negative is positive. Positive divided by a positive is positive. But if your signs are opposite, then it's negative. So same thing. So in each interval, you need to pick a number in each interval we can test. Okay. So here in the middle, I already have 0. We'll use that. Over here, let's use -3 as our test point. And over here, we'll just use 4. Okay. Now, if I plug -3 in for x here, that'd be -6, which is negative. If I plug -3 in here for x in this one, -3 plus 2 is a -1. It's still negative. And so we know that that function, or f of x, remember f of x, we defined as x minus 3 over x minus 2. Let me actually write that again up here so we don't have to move up the screen to see it. Okay. So then negative divided by negative then, of course, is positive. Let's move to the middle section. Okay, if I plug in 0 for x here, that's just -3. That's still negative. If I plug in 0 for x here, 0 plus 2 is +2. That's positive. And so in the middle then, I have a negative divided by a positive, which is negative. And then finally over here in this interval, if I plug in 4 to both, 4 into the first one, 4 and -3 is +1. That becomes positive. And the other factor, plug 4 in for x, 4 plus 2 is 6. That's also positive. So here, a positive divided by a positive is positive. Okay, so everything we need. So remember what we're trying to find is this right here. X minus 3 over x plus 2 is greater than or equal to 0. Okay, that was your f of x. Where is that greater than or equal to 0? Well, it is on the intervals to the outside. So so I don't have to leave this up. Let's put our solution over here. Okay, so it's positive in this interval. From this interval goes from negative infinity to -2. Okay, in this case, parentheses. Now here, -2 was where we had an asymptote, a vertical asymptote. That's where it was undefined. And we say it's undefined at -2. So that endpoint, even though this is greater than or equal to, that point is not included. Okay, but this one here, this interval from 3 to infinity. Okay, in this case, the 3 is included because it's greater than or equal to. Once again, remember here the -2 is not included because there was a vertical asymptote there. It's where it's undefined. And then finally use the union sign in the middle. Now, once again, let's go to Desmos and take a look at that and see if that appears realistic. Okay, if that's correct. So let me change this. So our function, call it y or not, was, and also to do a fraction like this, use parentheses for your numerator. It was x plus 3. I'm sorry, x minus 3 over x plus 2. X minus 3 divided by x plus 2. Okay, now there's our intercept. Okay, now we said it should be undefined at -2. Let's actually draw in a vertical line. So do that as x equals -2. Okay, that's our vertical asymptote. And remember, graph cannot cross a vertical asymptote. Let's see if this is true. So we said it was negative, whereas positive from negative infinity up to -2, and that's true because at a vertical asymptote, a graph will get close to a vertical asymptote, never actually cross it. So the closer x gets to -2, well, the graph will keep on getting closer and closer to that line, that vertical line. Okay, then it's negative between -2 and 3, and then once again positive beyond 3. So that's the correct answer. So you get that either graphically or algebraically by hand. All right, so it's useful to see both approaches. Either one will work legitimately, and in many cases, if you have something that you can't actually factor, a lot of times it may be better to do it graphically. So what we learned then is the algebra, what's called the algebraic method of solving polynomial rational inequalities by hand. Thank you. Have a good day.